In this video, we want to learn about factoring by grouping method. Whenever in an expression we have 4 terms or more, we can think to factoring by grouping method. In this method, we group the terms and we try to find a common factor between each group and we factor that common factor. Let me show you how this method works. Look at this first example, x to the 3 plus 9x to the 2 plus x plus 9. We consider these two terms as a group. And if you pay attention, we have a term common between these two terms. First of all, note that we don't have any common term in all the terms. But if we consider this as a group, we have something common between these two terms. What is the common factor between x to the 3 and 9x to the 2? The common factor is x to the 2. So we factor x to the 2 from these two terms. If we factor x to the 2 from these two terms, from the first term we have x, and from the next term we have 9. And we leave the next two terms, x plus 9, because nothing is common between these two terms. Now we notice that x plus 9 is common between these terms and this term. Attention, this is a term separate from this term, because between them we have a plus. Now, from these two terms, we can factor this common term, this common factor basically. If we factor x plus 9 from this and from this, from the first term we have x to the 2, so times by x to the 2, and from the next term we have 1. And this is the answer for this question. Look at the next example. 3x to the 3 minus x to the 2 plus 12x minus 4. Same method as the previous example. We consider these two as a group. We can factor x to the 2. Then we have 3x minus 1. From these two we can factor 4. And then we have 3x minus 1 again. And because these two factors are the same, they are both 3x minus 1, we can factor these. From these two terms, we can factor 3x minus 1, and then we have x to the 2 plus 4. Look at the next example here. Now look at this example. We consider these two as a group again. We can factor 9x to the 2 from these two terms, and then we have x plus 2. From these two terms, we can factor a negative. If we factor a negative, then we have x plus 2. And x plus 2 is common between these and these. We factor x plus 2. And then we have 9x2 minus 1. Here, in this second bracket, we have 9x to the 2 minus 1. If you remember the difference of a square identity, if you remember this identity, a2 minus b2 can be written as a minus b times by a plus b. Based on this identity, if you pay attention, this fits with this part. A to the 2, 9x to the 2 is basically 3x to the 2. Minus 1 is basically 1 to the 2 or 1. So we can factor 9x to the 2 minus 1, and so we can factor this a little more. We leave x plus 2 here. Then this can be factored as 3x minus 1 times by 3x plus 1. How we get this part? For finding a, we take a square root of 9x to the 2. Radical 9x to the 2. Radical 9 is 3. Radical x2 is x. In this way, we can find a. And radical 1 is 1. And this is the fully factored form of this given expression here. Before we move to the next example, let me mention something here that it can help you to figure out if a factoring by grouping method works for an example or not. Look at this first example that here we had. The ratio, attention to the ratio between the coefficients, 1, 9, 1, 9. Same ratio, 9 over 1, 9 over 1. Look at the next example. 3, negative 1. Here the coefficient is 3. The coefficient here is negative 1. 12, negative 4. 3 over negative 1 is the same as 12 over negative 4. 12 over negative 4 is negative 3, and 3 over negative 4 divided by negative 3 divided by negative 1 is also negative 3. So the ratio is the same. If you pay attention, 3 multiplied by 4 is 12. Negative 1 times by 4 is negative 4. You can see that we have a relation between these numbers. Not always, but most of the time. 9, 18. 9, 18. Look at the ratio here. Negative 1, negative 2. Negative 1, negative 2. If you divide 9 by 9, it's 1. 18 divided by 9, 2. Or in the opposite way, negative 1 times negative 9 would give you this number. Negative 2 times negative 9 would give you this number. So there is a relation between the coefficients in the expressions that we can factor them by grouping method. Now look at these examples here. First, we have a complicated example. X to the 5 plus x to the 4 plus x to the 3 plus x to the 2 plus x plus 1. If you want to choose in this way grouping, if we group these in 3 groups, if you pay attention, the ratio of the coefficient 1, 1, 1, 1, and 1, 1. The ratio is the same. Basically, the coefficients are all the same. So immediately we start by grouping these two. We put these two in a group. We factor x4. Then we have x plus 1. From these two, we can factor x2, then x plus 1. And from the last two, we don't have anything to factor. We leave them as x plus 1, but we put a bracket to make it more clear that x plus 1 is the common factor. If we factor x plus 1, what remains from the first term? x4. From the next one, x2. From the last one, 1. And this is the factored form of that expression. Look at the next example. 1, 1, 3, 3. So 1, 1, 3, 3. Can you see the similarity between coefficients? Can you see the ratio is the same? 1 times 3, 1 times 3. So there is a relation usually between the coefficients, as you can see here. So x to the 2 plus xh, what is the common factor between them? X. So we factor x, then x plus h. Then we factor 3, 3 times x plus h. If we factor x plus h, then from the first one we have x, from the next one we have plus 3. Look at these examples. 6x to the 2 plus 3xy minus 4x minus 2y. First, let's see, do we have any pattern, any relation between coefficients? 6, 3, 4, 2. If you consider the ratio between these two, 6 divided by 3 is 2, 4 divided by 2 is also 2. There is a relation, as you can see, between the coefficients. Let me tell you another thing about the coefficients: 6, 3, 4, 2, or negative 4, negative 2. If you divide basically 6 by 1.5, you would get 4. 3 divided by 1.5 would give you 2. Or in opposite word there. If you multiply 4 by 1.5, it would be 6. 2 times 1.5 is 3. We factor from these two a 3x. Then we have 2x plus y. Then from these two, we can factor a negative 2. And then we have 2x plus y as well. Then we have a common factor between these two, which is 2x plus y. If we factor this, from the first term we have 3x, from the next one minus 2. If you want to learn more about factoring the common factor, like these factors that we do here, I have a video about factoring the greatest common factor. That video can help you to do these kind of operations that I am doing here really easily by yourself. Look at the next example. 20x to the 2 minus 12x minus 18y plus 30xy. You can check for the coefficients that there is a relation between the coefficients. Let's start factoring. What is common between these two terms? 4x. If we factor 4x, then we have 5x minus 3. Now look at these two terms. What is common factor between them? Y is common. Between 30 and 18, 6 is the common. So we can factor 6y from them. If we factor 6y from, please pay attention, from this term, we get 5x. From this term, we get negative 3. Basically, we have to write this in the form of negative 3 plus 5x. But because we want to have same format, same exact expression, I prefer, instead of writing this, I prefer to write it this way. These two are the same. Of course, they are the same. Negative 3 plus 5x or 5x minus 3. They are the same, but we prefer to write it this way. Now, we factor this common factor, and then we have 4x plus 6y. But please pay attention. When we look at this expression, what we see? We have a common factor. What is that common factor? 2. So we can factor a 2 from this bracket and we can put it outside. So the final answer can be written in the form of 2 times 5x minus 3 times by 2x plus 3y. So from these two we factor 2 and we put the 2 outside. You can put 2 in the middle between the two brackets, but it's not a really good idea. It's better to put in here. And this is the factored form of this given expression here. Now look at this example. A to the 6 plus b to the 6 minus a2b4 minus a4b2. In this example, if you notice, if we consider these two as a group, we don't have anything common between these two. Is there any common factor between these two? No. So maybe we have to think to changing the order of these terms here. Maybe they made it harder for us by changing the order of the terms. So we have to adjust the order of the terms. So we are looking for a term between these terms that if we move it to here, then there is a common factor between a to the 6 and that term. If we move, for example, this term to here, yes, there is a to the 6 and a to the 2 common factor, but a to the 4 would be better because a to the 4 and a to the 6 have a to the 4 as the common factor. So here, in this tricky question, first, we write the expression in the form of a to the 6 minus a4b2. Then we write b to the 6 minus a2b4. So we did so far basically nothing. We just move this term from here to here. And we can of course do this. This is the same expression as before. Now we consider these two as a group. What is common factor between a to the 6 and a4b2? a4. So we factor a4 from them. So we have a4 times a2 minus b2. From these two terms, we can factor b4. And then we have b2 minus a2. But the thing that we notice here is that in this bracket we have a2 minus b2. In the other bracket we have b2 minus a2. They are similar, but they are not exactly the same. So here you can think to factoring. Please pay attention to this. Here, because we want to have same bracket as this here also, instead of factoring only b to the 4 from these two, we can think to factoring negative b to the 4, because if you factor an extra negative from these two, then the order of these two terms would change. A to the 2 comes here, b to the 2 goes here, and then this exactly would be the same as this. So please pay attention, because we want to have same bracket as this one here. I'm going to factor not b to the 4, I'm going to factor negative b to the 4. So we are going to factor negative b to the 4. What happens if we factor negative b to the 4? From this term we would have negative b2. Please pay attention, if we multiply this by this, it would be b to the 6. From the next term, because we factored negative b to the 4, what remains from the next term? We have plus a to the 2. If you multiply this in this term, you would get exactly this. Negative times plus would be negative. b4 times a2 is this term. But still I don't like this expression, negative b2 plus a2. This expression is exactly this. But the way that we have written this expression is the thing that I don't like here. Negative b2 plus a2. Negative b2 plus a2 is exactly the same as a2 minus b2. It's better idea to write the term with positive coefficient first, then put the negative in the middle. This is the same as this, but which one looks better? a2 minus b2 or negative b2 plus a2? Which one is better? Of course a2 minus b2. Let me tell you the reason. For example, consider this negative 5 plus 2 and compare this with 2 minus 5. Yes, this is negative 3. This is also negative 3. But this looks a little maybe better. So I prefer to write this expression in the middle in the form of a2 minus b2. So it's up to you. You can leave it as negative b2 plus a2. As long as you know that it's the same as a2 minus b2, you are fine. But I prefer to write it this way. Now we factor this common factor. a2 minus b2 is common between this term and this term. If we factor that, what remains? From the first term we have a4, from the next term b4. Now look at this. a2 minus b2 can be written as a minus b times a plus b. Remember the difference of a squares identity. a2 minus b2 is a minus b times a plus b. This is very famous, important identity that we have to know. Based on this identity, we can write a2 minus b2 in this form. What about a4 minus b4? Based on that identity, again, based on the difference of a squares identity, we can write a4 minus b4 in the form of a2 minus b2 times a2 plus b2. Let me explain to you what happened from here to here. When you want to use this identity, basically in the right side, what you have to write? If it is a2, you have to put a here. So a square root of whatever is here, we have to put here. Here we have a to the 4. What is a square root of a to the 4? 4 divided by the index 2 is a2. That's the reason that in each bracket we have to put a to the 2 and b to the 2 for same reason. Again, we notice that this can be factored as a minus b, a plus b. But what about a2 plus b2? We cannot do anything with that. We cannot factor that. We leave it because it's plus between. Now look at this answer. This is 100% right, and this is the fully factored form of the given expression. But the thing that I notice is that a minus b is repeated factor. You can combine these two and write it as a minus b to the 2. And for a plus b, it is repeated. You can write as a plus b to the 2. a2 and b2, don't forget we have this at the end. So you can write this final answer in this more compressed format. It's up to you to write this final answer or not. This was really challenging question compared to the previous questions that we have done so far. Before I finish this video, let me show you another way that you can do this question. Maybe you wonder what is the benefit of another way. We did this question right now. When you do a question in two different ways, you will learn different techniques. It's good to review different techniques in factoring. So let me show you another method for factoring a6 plus b6 minus a2 b4 minus a4 b2. If you remember, when we started this question, we changed the order of the expression and we moved this to here and we moved b to the 6 after. And then we factored with the grouping. And the reason was that when we look at these two, we don't have any common factors, so we think that the common factor method, the grouping method, basically doesn't work. Here I want to show you another method for doing this question. Again by grouping method, but with a different technique. Look at this. I consider these two as a group and I consider these two as a group. Maybe you think by yourself, if you consider these two as a group, how you want to factor this then? Here I want to use an important identity, which is very important for you to know this identity. That the identity is this identity. A to the 3 plus b to the 3. The sum of cubes identity. A to the 3 plus b to the 3 can be factored as a plus b times a2 minus ab plus b2. I know maybe some of you are not familiar with this identity, but it's good to know this formula for more advanced math courses. A to the 3 plus b to the 3 can be factored in this way. Now here we have a to the 6 plus b to the 6, but attention, 8 to the 6 plus b to the 6 can be written in the form of a to the 2 raised to the 3 b to the 2 raised to the 3, because a2 to the 3 is a to the 6, b2 to the power of 3 is b to the 6. When power raises to a power, we multiply the powers and it's 6. So for these two terms here, I want to use this relation for factoring. And attention, this is a and this bracket is b. The power is outside. Based on this identity, what is the factored form of the first group? The factored form would be a plus b, a2 plus b2 times by this big bracket. What is a to the 2? What is this term to the 2? a2 to the 2 would be a to the 4 minus ab minus this times by this minus a2 b2, and finally b2 to the 2 would be b to the 4. And that's it for the first group. For the next group, it's easy. Look at the two terms that we have in the next group. What is the common factor between them? The common factor between this group is minus a2 b2, and then we have a2 plus b2. So we factor a2 b2 and then we have a2 plus b2. Now look at this and look at this. We have a common factor between them, a2 plus b2. So we can factor this from these two. So basically we can write this as a2 plus b2, and then we have a4 minus a2 b2 plus b4. This is from the first term, and from the next term, if we factor this, this is what remains from this. We have minus a2 b2. This term is similar to this term, so we can combine these two. So we can write this in the form of a2 plus b2. Then we have a4 minus 2a2 b2 plus b4. Now look at this bracket. This is a perfect square. If you are familiar with the perfect square identity, you can figure out that this is a perfect square. This second method is a little more advanced compared to the previous method. You need to know many different identities, but it's good to learn this. Again, this is a perfect square. Perfect square. If you want to learn more about the perfect square identity, and when we use that identity for factoring, watch my video about perfect square identity and perfect square identity application for factoring. Why this is a perfect square? Because I noticed that this term is a perfect square. A4 is basically A2 to the 2. B4 is also B2 to the 2. Let me write down this here for you to make it at least a little clear. A4 is A2 to the 2. B4 is B2 to the 2. And if you pay attention, this middle term is exactly A2 times by B2 times by this extra negative 2. Whenever the middle term is twice of the product of these two, A2 times B2 is A2 B2. Twice of that is 2A2 B2. If the middle term is 2A2 B2 or negative 2A2 B2, this confirms that it is a perfect square. So we can write this in the form of A2. Based on the perfect square identity, we can write this as A2 minus B2. This is what goes here, and this is the other term that goes here. A2 minus B2 to the 2. But if you pay attention, still this is different than the answer that we got from the previous method. A2 plus B2 is the same, but this part is a little different than this. The reason is that if you pay attention, A2 minus B2 can be factored as A minus B times A plus B. Please pay attention. I'm going to write A2 plus B2 again here. A2 plus B2. I factor this and I write this as A minus B, A plus B. But attention, we have a power 2 outside and we have to put this power for each of these brackets. So a power 2 for this, a power 2 for that. And now, if you compare this answer with the answer from previous method, you can see that they are the same. This answer is exactly the same as this answer. The order of the brackets is changed, but the order in multiplication of brackets is not important at all. I know this last question was really challenging. You should not be worried for examples like this. These are a little advanced, but it helps you to learn different techniques and combine them in one example. I hope by watching this video you have learned about grouping method. If you like this video and you want to watch more videos like this, please subscribe to my channel and see you in the next videos.